the Abbey Road Observatory. I'm your host, Jim the Filter Guy. I'm sitting here with two of my favorite cameras, the ZWO ASI 533MC Pro color camera and monochrome camera Mallancam DS432M Tech. These are the two cameras that I love to use when I do electronically assisted astronomy, which is the topic of today's video. But before we get into that, why don't you take a moment to click like down below if you like these videos that I'm doing. And if you want to stay up on all the latest news from the ARO, click subscribe. Alright, let's get on with talking about electronically assisted astronomy. Welcome to my video titled The How and Why of Electronically Assisted Astronomy. Over the course of the next half hour or so, I will describe what exactly EAA is, and attempt to convince you that it is an aspect of amateur astronomy that you should be looking into. So let's consider, if we will, this view of the Orion Nebula. This is a relatively bright object in the winter sky. This is a simulated picture of the best view that I've had of this object through a telescope with my naked eye from a dark sky and using a filter to help improve the contrast, something called an oxygen 3 filter. But what if instead of this view, you could have this view? This is a screen capture from a live viewing session from my backyard here in central Ottawa, with a light pollution filter installed on the camera. This is what I am talking about when I say electronically assisted astronomy. The term EAA is sort of an umbrella term, and it captures a lot of different technologies that are available today to assist you with your observing. It includes video astronomy, night vision goggles, short exposure imaging, and near real-time observing. All are captured by this one category of observational astronomy. The idea is that you're using an optoelectronic device to replace your eye as the device gathering all the light, gathering the actual photons from what it is that you are observing. The main objective for EAA is observing, although this is sort of a gray area, since it does overlap quite a lot with astrophotography. There are several technologies available, as I will explain next. The technology that you use depends really on how quickly it is you want to see the object. If you want to see it sort of in the sub 1 second time frame, so practically real time, then you would choose night vision goggles. These are light amplification devices developed originally for military use, but now you can get them from hunting stores and other similar retailers. If you want something that's more in the seconds to tens of seconds range for how long it takes to get an object, then an analog video camera is what you should be looking at. There's a number of choices available for that today, starting originally from using security cameras, but they've now evolved from there. After that, if you're thinking, yeah, I can accept it taking tens of seconds to several minutes to get me an acceptable image for observing, then you can look at a digital video camera. So a camera like what one would use on the moon or planets can also be used for this application, what some people refer to as short exposure imaging. The individual exposures are short, but you are stacking many of those frames on top of each other with readily available software. Finally, if you don't mind it taking tens of minutes to hours to collect your image, then you've moved into traditional astrophotography. The scale I have plotted here, moving from left to right in increasing time, is also increasing in the quality of the image. So the quality of image that you get from a night vision goggle is not going to be anything like what you would get from traditional astrophotography. And there's a continuous range of image quality pretty much paralleling the length of time it takes to get the image. Moving now to the benefits of using EAA. One is that you can see more of what's in the sky. This plot on the left compares the spectral response of the human eye when it is dark adapted, that's the blue line, to a typical CCD sensor, shown in red, like you would find in a modern camera, in this case a monochrome camera. You can see the amount of the spectrum that the camera can detect is much wider than the human eye. The human eye can actually only see quite a narrow part of the electromagnetic spectrum. I've also drawn on here some wavelengths of light that are useful to us for deep sky objects. The HB stands for hydrogen beta, up here. Oxygen 3 is O3. C2 is an emission from carbon molecules that we often see in comets. HA stands for hydrogen alpha, and then nitrogen 2 and sulfur 2. Except for the C2 molecule here, these are all wavelengths of light that are emitted from nebulae. You may notice that there's a whole group of these emissions, all these over here in the red part of the spectrum, that humans can't see at all when our eyes are dark adapted. If it wasn't for using a camera, we would have no way of seeing these emissions at all. So that is a definite advantage to using a camera to gather the light for us. Another advantage is that cameras are much more sensitive than our eyes. We can see things much fainter than we would with just our naked eyes. Another advantage is we can see in color with a camera. The human eye, when it's dark adapted, is using the rods instead of cones in our eyes, and as a result we don't perceive color very well. We tend to see mostly grays and greens, but a camera can easily see color in the dark. Another advantage is we can apply filters to make the output from our cameras much better quality. We can use them to get rid of light pollution. We can use them to improve contrast, that sort of thing. There's also many software tools available to help process and enhance the view in real time that you wouldn't have if you were just using your eyes. One advantage that I like is that you can use remote viewing. So for me, I'm sitting comfortably in my basement, and I don't really care how cold it is outside, or how many mosquitoes there are. I can still observe comfortably regardless of what the conditions are outside. So that is a handy benefit. Another advantage is you can overcome issues with your vision. As you get older, you may have issues with your eyes that does not allow you to use a telescope with an eyepiece. And so using a camera and putting the image up on a screen can really help save astronomy for you. The last benefit of EAA to mention is outreach. It's much easier to share an image of an object on a screen where everybody can look at it at the same time, as opposed to taking turns looking through an eyepiece. Before moving on, I'd like to come back and reiterate the benefit of using filters to block light pollution. Consider this image of the Western Veil Nebula captured using my EAA setup from my heavily light-polluted backyard in central Ottawa, Canada. You can see the nebula, but it isn't all that impressive. Now let's add a multi-narrow band filter. specially made to block as much light pollution as possible. I believe you agree that the difference is significant. By combining a properly selected filter to a camera, you can observe pretty much whatever you want from your urban backyard. So here is a typical EAA setup. We have a telescope. It's set up on a motorized mount, so it's able to track the sky. Also, we can use the computer inside the mount to point it at objects that we want to look at in the sky. Next, in the place of the eyepiece, here, we put a camera. It's the same interface as an eyepiece. We're just putting it in the same place on the scope. The same two types of interfaces are available, the 1 1/4 or the 2-inch diameter. The signal from the camera can go either to a monitor, as shown here, if you just want to look at the video by itself, or if you do want to do a little bit of work on the image, you can have it connect to a computer. From the computer, you can do all kinds of things. You can view the live video, you can control the camera, you can control the mount. With analog video cameras, you have the freedom to just go to a monitor alone or to a computer. But with more modern USB cameras, you have to use them with a computer to see the video. This is an example of my setup at my cottage from 13 years ago. The reason I'm not down on this lovely beach enjoying the fine summertime air, you can see the cables here trailing off into the distance. The reason I'm not on the beach typically is because the mosquitoes after sunset are completely mental. My computer, in this case, is actually in a sleep cabin up the hill with the scope down on the sand and all the wires running back up into the building. This is an example of a remotely controlled setup that you could have also. Since that photo was taken, thermocell bug repellent devices were invented, and now I sit on the beach with my EAA setup bug-free. This image was taken just this past July when I was still using my Meade LX65 Alt-Az mount as my travel mount. This fall I upgraded my travel mount to a Jouet 17 harmonic mount, seen here on the left side of the image. I was at a friend's place during a star party just this past September. So, what do you need to get started in EAA? Well, the first thing you need to have is a telescope. And if you already have a telescope, then you're probably okay to start with what you have. There's no reason to go out and buy anything special. You can do EAA with pretty much any type of scope. To get the most out of it, though, you're going to want a tracking mount. I'm not saying you couldn't use a Dobsonian-type push-pull mount, but to really get all of the benefits out of the use of the technology, you should have a tracking mount. Alt-Az type mounts are okay, but you get the best tracking from an equatorial mount. For many years, I have successfully used an Alt-Az mount as my travel mount, so it is entirely possible. Having a mount with go-to capability is quite handy also. If you're doing remote viewing, it can really increase your productivity in an observing session. For cameras, you have quite a few choices available, and they range quite widely in price, from the $100 to $300 range all the way up to multiple thousands of dollars, depending on the capability of the camera that you want to purchase. Probably the biggest OEM for such cameras is ZWO, a Chinese company. But there are several other brands to choose from, like Player One, Altair Astro, and SV Boni. The final thing that you need to have is some way of displaying the video. If you're using an analog video camera, like these three here, this one, and this one, those are all analog videos, you can put the video right into a TV monitor. You don't need to have a computer. You can just watch the video stream separately. The other cameras shown here are all digital video. They use a USB cable to connect to a computer, so you must have a computer and the associated software to view those cameras. One relatively new method for viewing the output from a digital video camera is to install a purpose-built microcomputer at the telescope, which also acts as a wireless hotspot. You can use your phone or tablet to then control the camera and view the resulting images. The ASI Air, made by ZWO, is a popular version of this device, but there are other brands available also. Now, you may have noticed that all of the cameras displayed here have the name Mallencam on them, the reason for which I will explain now. A large part of the reason why I am active in electronically assisted astronomy has to do with the fact that I live in Ottawa, Canada. Also from the Ottawa area is one of the pioneers of electronically assisted astronomy. His name is Rock Mallon. He was one of the first people to experiment with analog video cameras to see what could be done to adapt them to the role of looking at objects in the night sky. He started this work back in 1995, and he has developed the technology to the point where he has quite a wide spectrum of cameras available for commercial sale. If you want more information about the products that he has for sale, you can go to his website, mallencam.net. Now for a bit of my own experiences. I've been doing EAA since about 2010. What really got me into this hobby was the now defunct website called Night Skies Network. This was a site started up by Rock Mallon and was a central site where astronomers from all over the globe could log in and share a live stream from their computer. It was this site that introduced me to the fact that this capability even existed. So now, whenever I observe, pretty much 100% of the time, it's using a camera from my backyard. The convenience of having a setup that's just ready to go, say after I've had supper, done whatever chores I need to do, and if it's clear skies, boom, I'm ready to go. It's really great to have that convenience and also not have to worry about traveling to a dark site to see anything. The cameras and the filters allow me to get around all those issues. I can honestly say that if it wasn't for EAA, I probably wouldn't be as active in astronomy as I am today, to be frank. To give you an idea of what an observing session is like from my backyard, this collection of images was captured in March 2019. This is from my backyard in central Ottawa, borderline plus skies, where I can see only a handful of stars at any one time because of the light pollution. So all of these objects were captured on the same night over the course of about 3 hours, same telescope, same camera. You can see it's quite a long list of objects. This is what I saw on the screen. I haven't touched these up or anything. These are just captures right off the screen of what I saw with my telescope that evening. Here are my captures from a more recent observing session, this one in late September 2025. In this particular session, I used 2 telescopes with 2 cameras simultaneously in order to put everything I was observing into context. This is the sort of thing that has kept me going in the EAA field. Basically, not having any limitations on what I'm able to see from my backyard. One thing that I should come clean on is the fact that you do need some technical ability to assemble and run an EAA setup. There are a number of connections and computer drivers and software to deal with. If that fact turns you off of EAA, then never fear. Robotic telescopes are here. These all-in-one devices require practically no tech savvy to operate. You simply turn it on and drive everything from your phone or tablet. There are now a number of different brands and models available to choose from. Well, that is it for my talk. If anyone has a question about electronically assisted astronomy, please feel free to leave a comment below. If you enjoyed this video, please don't forget to click the like button. If you want to stay connected to what's happening at the ARO, hit subscribe. That's all for now. Until next time, cheers.